Let's move now to segmentation. So we have this process A in memory. This is from the previous example. And we know that if we look inside what is the content of A in memory, we have different parts in the process. This we discussed in the very beginning. We have stack, heap, data, and text. So what if instead of talking of a process as a single monolithic block that goes from 0 to max, we actually start distinguishing different parts for the process? This could be motivated by the fact that we know that the different parts of the process have different purposes. There is one that keeps only text, that is basically instructions that are run by the process and taken by the CPU. There are global variables in another part. So each part has its own meaning, and some might need protection that is different from that protection needed by others. And they can also have different sizes. Some of them might be fixed, some of them might be actually variable. So there is a reason to differentiate between the different parts. Well, with segmentation, the idea is that instead of keeping a single pair of where the process starts and what is the limit, we keep a lot of, or a certain number of these pairs, one for each segment. And a segment is just one portion of the process, which could be one of the different parts. So we can say that we have 4 segments, one for the text, one for the data, one for the heap, one for the stack. They are numbered 0 to 3. And now for each such segment, we have the first physical address and the limit, okay? It allows you to check with finer grain resolution what is happening, because now it's not just checking whether you are addressing the memory of the process, but also checking whether you are trying to enter into, let's say, the data section or the heap or the stack and so on. You can even have different permissions for the different segments. For example, you can put the permission to execute only to the text section, because that is where you keep the instructions. And you could, for example, say that that cannot be written, but can only be read, for example. So you can protect a bit better the process, because no one can try to tamper the instructions and change the code that you are trying to run. And of course, the nice thing here is that now you can have the different segments at different positions in memory. You don't need to have a contiguous set of addresses to contain the entire process. So this is how it looks like. You need to introduce, in this case, a table in which you keep track of all the different starting addresses and limits. So you have one entry in the table for each segment. Line 0 is for segment 0, line 1 is for segment 1, and so on. And for each segment, you have the limit and the base. Okay, this is just a picture showing that one process has several segments in this case, and they are distributed around the memory. This is what I just said, that you need to keep, of course, track of the different limit and base numbers. You also need to complicate a bit the hardware in this case, because you cannot translate, you cannot check, as we did before, if you are trying to access a logical address that is below the limit, and then if that is the case, just sum the base register or the relocation register. Here you need to specify what is the segment you want to access, and then you will need to specify the address inside that segment. So given the segment, you can go to the segment table and take the respective entry for that segment. And then this will give you the limit and the base address. If you are trying to access something that is within the limit of your segment, it's fine. Then you can just sum here the base and get access to the physical memory. Otherwise, there will be an interrupt, so that you can wake up the operating system, and the operating system can take a decision about what to do with this process.